So my data project is on mortality in Australia. So in this presentation, I'll be looking at how the mortality rates have changed in the past millennia, and also how it has changed in the past 3 years, from 2015 to 2017. So at first, I looked at the number of deaths and how it's changed from 1907 to 2017. And from this graph, you can see that the number of deaths has increased over time. And there's a small spike around the 1920s. And it increases dramatically over time. And currently, around 2017, it's around 160,000 deaths per year. After that, I looked at the potential years of life lost over time. So potential years of life lost is the measure of premature death and the reasons behind it, and how you minus it from how much they were expected to live and their age at death. So when I look at the potential years of life lost from 1907 to 2017, I see that it has increased over time in the general trend, but there are still also the same spike in the 1920s. So after plotting these two graphs, I decided to compare the potential years of life loss and the number of deaths, because I thought that due to an increase of the number of deaths, the potential years of life loss will be increased as well. But when I plot them against each other, I received that it has an inverse relationship instead. So that is that the higher number of deaths meant a lower number of deaths meant a higher potential years of life loss, while a lower number of deaths had a higher number of deaths had lower potential years of life loss. So I was also then planned what could these causes be. So I looked at the child deaths from 1907 to 2017, and from that I made a bubble chart. So from the bubble chart, you can see that with a high number of potential years lost and a low number of deaths, there were more child deaths, and that could contribute to the high potential years of life loss at a younger age. And we minus from the expected age of death, there'll contribute a larger amount. And as you see at the end, there's a higher number of deaths but lower potential years of life loss, but the child death is dramatically less compared to at the beginning of the graph. So after that, I looked at the changes in life expectancies, and from the previous graphs, I assumed that life expectancy would have increased over time. And you can see that here that from the 1880s to around the 1950s, there has been a sharp increase. After that, it's time to slow down. And then from the 1990s and onwards, it's like a steady increase until the recent years, it's around the same for the males and females. So now I decided to look at the mortality rates in the recent years, and I looked to focus on 2015 to 2017. So at first I saw that overall, the median age of death was at 81, which is pretty high. And I then looked at the distribution of the deaths amongst the age groups, and I can see that there is a peak around the 80s to 90s in the males, and the same thing for the females. However, you can see that females' number of deaths seems to be higher compared to males, with a peak around 90 to 94. So then I thought, what are the leading causes of these deaths right now? So if I look at it, you can see that I made a lollipop chart on the top 20 causes of death from 2015 to 2017. And the leading cause of death was coronary heart disease, and then second was dementia. So after listing these causes, I thought, how are these distributed amongst each age group? So I made a heat map to show the distribution. And you can see that around the ages from 85 to 94, that's where majority of the deaths occurred. And it went with dementia and coronary heart disease, which shows the relationship between the previous graph. But as we look at the younger age groups from 1 to 14, 15 to 24, and 25 to 44, that many of the top 20 causes aren't the cause for their deaths. So I decided to look at those 3 age groups in more detail and what could be the causes behind it.
Almost done.
Okay, so if I look at the 1 to 14, the highest was land transport and then some other conditions originating from birth. And I made a bar chart to show the distribution, and we can see that land transport contributes to one of the highest amongst in the age 1 to 14. I then looked at 15 to 24, and I can see that there's a large proportion which is contributed caused from suicide and land transport compared to the other causes, which are really minor. Looking at the bar chart, then I can see that there is a huge spike on suicide, and then there's a big gap between the first and second leading causes in that age group. I then looked at 25 to 44, and I can see that suicide and accidental poisoning and land transport were the main factors in here. So after that, I decided to see how the land transport and suicide has overall compared to others age groups. And if I looked at the number of deaths by intentional self-harm from 2015 to 2017, I can see that 25 to 44 contribute to nearly half of all the intentional self-harm deaths, which is large considering there are around 9 age groups, and one of them takes nearly half of it. I then looked at the land transport, and it's similar in the sense that 25 to 44 also contributes to a large amount considering there are 9 age groups as well. So in conclusion, as the years go by, number of deaths increases, but the potential years of life loss decreases. And we can see that child deaths is one of the reasons why these potential years of life loss has decreased over time, as child deaths has also decreased over time, and life expectancy has also increased. And overall, we can see that coronary heart diseases are the main cause of death, and that although majority of the causes in the top 20 aren't applied to the younger age groups, that land transport and intentional self-harm are the highest, the reasons for deaths. Yeah.
All right, thank you.
Yeah.
There was some really interesting stuff in there. The amount of the contribution of suicide to youth deaths is kind of terrifying.
Yeah.
I was interested by some of your early graphs which had spikes in the 20s. This is Australian data, right?
Yeah, Australian data.
And it was interesting to see that there weren't corresponding spikes between 1914 and 1918 and between 1935 and 48, or whatever it was, 42, 48. And so I was wondering, like, I think one of the things that, if you wanted to sort of upgrade this presentation a bit, would be to make it a little bit more story driven, because at the moment it's a little bit like, here are some graphs. These are very interesting graphs. They're very pretty. They're very competent, but it's difficult to draw a line between those things. And so trying to work out what do those things say? So make some sort of comment potentially that like the 20s was the depression, and so a lot of people basically starved to death, maybe, or something along those lines. Or what was the flat spot in the life expectancy graph? Like that was a few years. What was happening in those years? What caused it to go back up? I think that would have added a little bit of like humanity, I guess, to the thing. But otherwise, it was very impressive.
Yeah. Okay. Thank you.
Yeah.
Oh.
Go for it.
No, I just thought it would be interesting if like with the 1920s, the Spanish flu and coronavirus, whether you'd see a similar spike in the potential life lost in 2020. But that, like, the data isn't there yet, but would be interesting in the future.